Hey guys, it's Miss Richardson here. Sorry I'm missing our class today, but please watch my video instead of having class. And once you're done, send me a message so I will make sure I count you as present for class today, even though we're not meeting live, please. But we will meet together at our regularly scheduled time, okay? All right, so today we're going to continue with our discussion about proportions. We're going to talk about equations today. That's our main focus. These are our standards of excellence and our learning targets. So we have been talking about proportional relationships. They have a constant ratio or equivalent functions. The unit rate is also can be called the constant of proportionality. So when you have a graph of proportional relationships, it must be a straight line, and it does go through the origin 0, 0. The unit rate or constant of proportionality, same thing, can be represented in verbal situations, tables, graphs, and equations, which we will focus on today for this lesson. So it is important to remember the vocabulary. Proportions can be represented by the equation y equals kx, and that k in math algebra always represents the constant of proportionality. Why isn't it a c? I do not know, but it is a k. All right, so on all of these tables, or this table, this graph, they can all, an equation could be written to represent all of these situations. So here's our equation, y equals a number times x. To find the constant of proportionality from tables and graphs, you always divide y by x. K equals y divided by x. So this table, the constant of proportionality, I hope you realize, is 3, right? So what does y equal in each one of these situations? The value y equals 3 times whatever x is. So here, since x is 4, 3 times 4 is 12. That's what y equals. 21, y equals 3 times 7. And 10 times 3 is equal to our y, 30. Okay, our graphs always look like this. Straight line goes to the origin, 0, 0. When x is 1, whatever the value of y is, that is our constant of proportionality, also called the unit rate. All right, so we'll move forward. This is a great video of him showing you, this guy showing you how you will find equations from graphs and tables. So that would be a great video for you to watch as you're working on your assignments this week. So when asked to find or write an equation, there are some things to remember. Make sure the relationship is proportional. Find the constant of proportionality. So here we have a straight line goes through 0, 0, so we know it is proportional. So when x, so remember our horizontal axis is x. So when x is 1, the y value is the unit rate. That is the constant of proportionality. So in this graph, it is 6. Just making sure I actually started recording this time. Yep, so 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18, so on and so forth. So the constant of proportionality or unit rate in this situation is 6. The number of students divided by the number of chaperones each time simplifies to 6 over 1. So what is our equation? Y is equal to 6x. That would be our equation. Y is equal to 6x. Let's look at a graph. We looked at a graph example. Now let's look at an example in a table. So the first thing we're going to do is find our constant of proportionality. And the way we always do that is the constant of proportionality equals y divided by x. So we would write 180 over 6. We want to make sure that is equal to 480 divided by 8. We want to make sure that's equal to 300 divided by 10. And is that equal to 360 divided by 12? Well, the answer is yes. In every scenario, it's equal to 3. If any one of these is equal to anything other than 3 when we divide, it would not be a proportional relationship. So our constant of proportionality in this situation is 3. We divide the miles by, did I say 3, guys? I'm so sorry. 30. Just kidding. It is 30. Please excuse me. So 30 miles per gallon. So what would the equation be? Y is equal to 30 times X. Y would equal to 30 times X. Now let's look at a verbal example. It costs $5 to send 6 packages through a certain shipping company. Consider the number of packages per dollar. All right, so to find the constant of proportionality, we want to know the number of packages per dollar. So we're going to divide 6. It says per dollar. Almost always we divide our dollars by our quantity, but this is the number of packages per dollar. So this time we're actually going to divide 6 packages by $5, and we would get, oh, it's not dollars, it's 1.2 packages per dollar. Consider the number of packages per dollar, 6 divided by 5. At this point, we could solve it several ways: divide or create a table and find the unit rate, or set up a proportion. So 1.2 packages per dollar. So $5 for 6 packages, $10 for 12, $15 for 8, so on and so forth. So our constant of proportionality is 1.2. So what would our equation be? Our equation would be y is equal to 1.2 times x. Do you have it? All right, representing proportional relationships. You can represent a directly proportional relationship by the equation in the form of y equals k times x, where k is the constant of proportionality or unit rate. For example, football tickets cost $7 each. The equation that represents this situation is the amount of money, so y, your total money spent, is equal to $7 times x. So what does the y represent? It represents how much total money I'm going to spend. What does x represent? It represents the number of tickets we will buy. The 7 represents the price. You know, everybody can order a different number of tickets. And it asks, what is the constant of proportionality or the unit rate? And it is 7, because tickets cost $7 each. You can represent this information on a T-chart or an XY chart or a table, however you want to say it. So if y is equal to 7 times x, so if I bought 0 tickets, 7 times 0, I would spend 0 money. If I buy 1 ticket, x is the number of tickets, I would spend $7. 2 tickets would be $14, so on and so forth. I can also take that information and I can create a chart, or excuse me, a graph. So here's our number of tickets. Our X's are on the bottom. 1 ticket, $7. 2 tickets, $14, so on and so forth. All right, graphs that show that proportional relationships are straight lines and pass through the origin. Which graphs show a proportional relationship? Which ones in your mind show a proportional relationship? That would be letter A, straight line goes through the origin. B, straight line goes through the origin. C, straight line goes to the origin. Not D, right? It's straight, but it doesn't go through 0, 0. Letter E, is it proportional? No, because it's not a straight line. It does go through 0, 0, but it's not a straight line. And letter F is yes. It shows a proportional relationship. It's straight, it goes through the origin. Easy peasy, right? All right, the constant of proportionality, which is always found when x is 1, whatever y is, that is the constant of proportionality, also the unit rate. If you're looking for the unit rate, you can think of the point as 1 and then whatever that y value is. So time is our x-axis. Distance is the speed of a sloth. So we know sloths go slowly. So in 1 minute, that sloth walked a total of 6 feet. So what is our unit rate? What is our constant of proportionality? That would be 6, right? 6 feet per minute. What about this equation? We're going to write an equation. The total price of the oranges is equal to the number of pounds times $3. So $3 a piece. So how much money would we spend? The amount of money would equal to 3 times the number of pounds. That's our equation. Y equals 3x. Come on. Does this represent a proportional relationship? Yes. All right, the cost of a plumber, the total cost you would pay for the plumber is, the cost would be $25 for a fee to come to your house, plus the number of hours worked times 15. So the plumber makes $15 an hour, and he would charge you $15 times the number of hours, plus he would charge you $25 to come to your house. So this is our equation. So is this a proportional relationship? It is not, because I wonder if it shows me a graph. It does not. All right, so why would this not be proportional? Well, let's make a T-chart, all right? So let's say the number of hours the plumber came to your house is 0. So if x times 0, if 15 times 0 is 0, but 0 plus 25 is not 0, is 25. So I know that if a plumber comes, he doesn't come to your house, you shouldn't pay him $25, but this is how he charges his customers. So what if he works 1 hour? You would charge him the $15 fee to come to your house, because it takes gas and time to come to your house, plus he would charge you $15 times 1. So how much money would that be? Would that be $40? Yep. What if you work 2 hours at your house? Well, 2 hours times 15 is 30, and 30 plus 25 is 55? Yeah, I think so. All right, so if we graph this on a coordinate plane, would I start at 0, 0? No, I'd start at 0, 25. That would not go through 0, 0. Another way to tell is if I divide 20, or to find the constant of proportionality, we would divide y by x. Well, y divided by x on this situation, you actually can't divide by 0. So this would be undisclosed, or try in your calculator. If you typed in 25 divided by 0, it would tell you made an error. You can't do that. It's no solution, actually. So you can't divide by 0. But 40 divided by 1 is 40. And what is 55 divided by 2? Well, I know it's not 40. So whatever that number is, it's not 40. Okay. So a couple of different ways you can tell this is not proportional. So if it has anything besides just a number times x, if it has plus or minus another number, it is not proportional. It would not go through 0, 0. All right, find the constant of proportionality. If the x and y values increase at a constant rate, to find the constant of proportionality, you divide by x. All right, so you divide y by x. So what is 14 divided by 2? 7. What is 28 divided by 4? 7. 42 divided by 6, and 56 divided by 8. They're all 7. So what is our constant of proportionality? It is 7. And once again, when x is 0, y is 0. That line would definitely go through our origin. All right, does this represent a proportional relationship? Well, let's find out. 5 divided by 1 is 5. What is 7 divided by 2? Well, 7 divided by 2 is 3.5. What's 10 divided by 3? It's 3.33333333. And 14 divided by 4 is neither of these. So does this represent a proportional relationship? No. Y is not increasing at a constant rate. Write an equation for the graph and the table. So let's look at the graph first. So let's see, when x is First of all, it goes through 0, 0, so that's a good place to start. These are our ordered pairs. What about when x is 1? What is y? Well, it looks like it's right about 5. Don't you agree? What about x is 2? What is y? What about when x is 3? Does it look like it's about 15? So what do you guys think? What would we do to x each time to get y? Yep, we're going to multiply by 5. So y is equal to 5x. 5x for our graph. What about our table? Let's see, we have 0, 0. What's 6 divided by 2? It's 3. What's 12 divided by 4? It's also 3. 18 divided by 6? That is also 3. So what is our equation? What does y equal? We do what to x? We multiply by 3. Y equals 3x. Hope you guys are getting these right before I tell you the answer. All right, graph the equation on the coordinate plane. Is it proportional? So let's start with x is equal to -2. 4 times -2 is -2, and -2 plus 0 is 0. What if x were -1? 4 times -1 is -4. -4 plus 2 is -2. What if x is 0? Anything times 0 is 0, and 0 plus 2 is 2. What about x is 1? 1 times 4 is 4. 4 plus 2 is 6. And what if x is 2? 2 times 4 is 8, and 8 plus 2 is 10. All right, so let's graph these ordered pairs. So if we go -2, left 2, and then don't go up or down, it would start here. What about go left 1, down 2, left 1, down 2? What about 0? Wait, hold on, something's wrong. -4. Oh, wait, this is wrong. Oh, the first one's wrong. 4 times -2 is -8. -8 plus 2 is not 0, guys. I'm so sorry. It's -6. I was like, this is not going to make a straight line. I apologize. Please forgive me. All right, so this one should be -2, -6 right there. All right, and then this tells us don't go right or left, but go up 2. Don't go right or left, but go up 2. This one says from the origin, go right 1, up 6. So from the origin, go right 1, up 6. And this doesn't have, we don't have enough room to go up 10. So I know I can't draw a straight line. You guys know I can't, but oh my gosh, see. Ugh. So yeah, that's terrible. All right, so pretend it's straight. It is a straight line. It's supposed to be, but since it doesn't go through 0, 0, it does not pass here. This is not 0, 0. This is 0, 2. Is this proportional? No. And remember what I told you earlier, if there's a plus or minus any number, it's not proportional. It's not proportional. All right, now that you know how to write an equation using the constant of proportionality, let's look a little closer at the graphs. So these are our previous problems. These are the previous problems we've already looked at. Let's look at the graph. What can the graph tell you about our situation? Straight line goes through 0, 0. This tells you for every 6 students, there's 1 chaperone, 12 and 2. For every 6 students, there's 1 chaperone. So on and so forth. We can see these specific scenarios in the rates we found earlier. The graph also shows us the unit rate very clearly. When the x value, chaperone, is 1, we can see our rate. The y value is 6. The unit rate can be found when x is 1. Let's look at this graph. All right. Immediately, we know it's a straight line and goes through 0, 0 is proportional. So what would our constant of proportionality be? Well, when x is 1, that y value is the constant of proportionality. It's 30. So 1 hour takes it takes 1 hour to drive 30 minutes. It takes 2 hours to drive 60, 3 hours to drive 90, 4 hours to drive 120. This is the 0.00. Remember, to be proportional, the graph needs to go through the origin. The graph also shows us the unit rate, 30 miles per hour. Therefore, our equation is y equals 30x. All right, I want you guys to try to do these on your own. Explain the points in the terms of the situation, give the unit rate, write the equation. So what does this point mean? We would be able to save $30 in 2 months. What does this point mean? We would save $60 in 4 months. So what is the unit rate? What's 60 divided by 4? What's 30 divided by 2? So 1 would be what? 1 in 15. What's the unit rate? The unit rate is 15. So our equation is y is equal to 15x. Did you do that on your own? I hope so. All right, that's what they said. All right, look at this. Explain what K means. What does K mean? K is the constant of proportionality. Explain the points in this graph in terms of the situation. Well, this isn't proportional, right? That means that there was a cost to come into the park, and then there was a cost per number of tickets. So to come into the park, it would have to cost $20 because this person who bought 0 tickets still spent $20. And then when he bought 2 tickets, he spent $24. 4 tickets cost him, what would that be, 28? So the number of tickets are increasing by what? $2 a piece? Yep. Yep, to go into the park was $20 and the tickets cost $2 a piece. Okie dokie. When 2 tickets were bought, All right, I think that's it, you guys. All right, so thank you for watching the video. Make sure you send me a message that you watched the video and you practice the problems along with me, and I will count you present for today's class. And I will meet you guys at a regularly scheduled time tomorrow for social studies. If you need any help, let me know, and everyone have a great day.